Hello everyone, welcome to Vijay Chemistry. Today day 4. Okay. Today we are going to discuss very important theory in chemical bond that is called VSEPR theory, valential electron pair repulsion theory. Okay. First I will discuss a postulate, then I will go with the examples. Okay. Please follow. First point. It is given mainly by Gillespie, GLLLES, Gillespie and Neo, scientist name. That's very important point. It is applicable. It is applicable only for main group elements. Main group elements. So what are main group elements? That is called S and P block elements. S and P block. This is not for transition metal element. Not for transition metal element. Okay. Listen. For transition element. For transition element metal. For transition element. Okay. Which they element. Okay. Which they're going to have crypted model. Okay. Crypt model has been given. Okay. Has been given. Okay. Listen. The VSEPR theory only applicable for the main group S and P block. For D block, we are going to apply what? Crypt model. Okay. Crypt model not in JAM exam also. Okay. Now see. Now this VSEPR theory is based upon very important the repulsion between electrons. Okay, very important. Okay, based on the electron repulsion. Okay, the VSEPR is going to tell about the geometry shape of the molecule. Okay, this is very important. The structure or geometry structure which is having the minimum repulsion will be the most stable structure. Will be the most stable. Very important. Most stable structure. Very important point. This is most important. And this is also most important point. Okay. Now, most please note. What is note? Okay. Very important. Okay. The VSEPR theory, VSEPR theory, VSEPR has no relation with hybridization. Okay, hybridization different theory, VSEPR different. Okay, don't confuse both. Okay, hybridization theory. Okay, now what type of electrons? Please know. Very important. Type of electrons. Okay, types of electrons. Number one, lone pair LP. What is LP now? That is called lone pair. Okay. Now PV now that is called bond pair. This is called lone pair. This is bond pair. Okay. Now hard electron. That is called single electron species. Only one electron. Now pi bonds. Pi electron pair. Okay, this is what the type of electron in the molecule. Okay. Now type of repulsion, please know. Very important. That is types of repulsion. Okay. In basic lone pair and bond pair and a lone pair. Okay. In our BSc level, okay, MSc level, please note. First the lone pair repulsion. Then go with the lone pair pi bond repulsion. Then lone pair bond pair repulsion. Then lone pair hard electron repulsion. Then pi bond repulsion. Then pi bond pair repulsion. Then pi bond hard electron repulsion and bond pair repulsion. Okay. Now bond pair and hard electron repulsion and hard electron and a hard electron repulsion. Okay, this type of repulsion molecule. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, total 10 repulsion. Okay, now among 10, which is most three important. Okay, either lone pair, and lone pair, bond pair, and the bond pair, bond. Okay, it's a basic common. Okay, now please note how to find out the listen. For example, they give the any four of this repulsion. Okay, they will ask the repulsion order. Okay, now please note order of repulsion, order of repulsion. First point, very important. Please note repulsion directly proportional to number of electrons. Number of electron increases, repulsion increases. Okay, now very important, repulsion order. Generally what is repulsion order? Okay, lone pair and more repulsion compared to pi bond. Sometimes both are same. Okay, sometime only. Then bond pair and finally what? Hard electron. Okay, listen, for example, okay, this lone pair 2 electron, this lone pair, this total 4 electron repulsion. You got the point. This is lone pair 2 electron, pi bond 2 electron, 4 electron repulsion. Okay, go with this model. Lone pair 2 odd electron, this is 3 electron repulsion. Okay, among these 3, which is more repulsion, which is less repulsion, number of electron increase, repulsion increases. The first one 4 electron repulsion, and second one 4 electron repulsion, and the fourth one 3 electron. Therefore, the fourth one is less repulsion compared to one, and second and first one. You got the point. Okay, now I take any 2 molecule. Okay, any 4, 5 molecule, going to arrange the repulsion order. Okay, now see the repulsion order. You can find a simple. First, this is A, lone pair repulsion. This is A. Okay, lone pair pi bond repulsion, then lone pair bond pair repulsion, then bond pair repulsion, then lone pair odd electron repulsion. Okay, first we need to find out what number of electron repulsion. Okay, now see lone pair 2 about 2 plus 2 4, this 4 electron repulsion. This is 2 plus 2 again 4 electron repulsion. This is 2 plus 2 4 electron. Okay, bond pair again 4 electron. This is what 2 plus 1 electron 3 electron, which is less repulsion. Among this repulsion order, which is less one repulsion order? E is repulsion, less repulsion. Okay, now listen, other four are what? 4 electron repulsion, right? Yes or no? This all 2 plus 2 4, okay, 4 electron. Okay, now see, now listen, the first molecule lone pair, listen, what is repulsion order? Lone pair and pi bond and bond pair, right? Therefore this bond pair less compared to what? Because among A, B, C all involving lone pair. Okay, and D there is no lone pair because D is least. Okay, then go with the ABC. Okay, now this is bond pair, this is pi bond. Okay, which is more repulsion? Pi bond compared to, listen, if the electron count say, if the number of repulsion electrons same, we go with this repulsion order. Okay, for in this A, B and C, this also 4 electron repulsion, this also 4 electron repulsion. Therefore, I go with the repulsion order. According to repulsion order, compare lone pair and bond, pi bond and lone pair, bond pair, which is more repulsion and pi bond. Right? Therefore, bond pair is least. C. Okay, now this is pi bond, this is lone pair, which is more, so lone pair common, right? And BC also lone pair common. I go with only what? Competition challenge between what? Pi bond and bond pair. In this case, lone pair is bond pair, lone pair is pi bond, which is more repulsion, again lone pair. Therefore, B and A. Okay, this is a repulsion order. Okay, how to find a repulsion? First, we have to check the electron count. Okay, upon same number of repulsion is now, then go with this order. After less number of repulsion now, this is less number of electron now, it will be what? Less number of repulsion. Okay, this is a very important point. Okay, now note lone pair on the fatty, it occupies maximum portion of molecule. Bond pair thinner. This is a thin. Okay, please note. Okay, now. Okay, you can try this question. Okay, this homework. You can try this question. Pi bond lone pair, bond pair. This is bond pair. Okay, this is A. And bond pair and odd electron. This is B. Okay, now pi bond and odd electron. This is C. Okay, now lone pair and odd electron. Okay, this is D. Okay, among these 4, tell me the order which is more repulsion, which is less repulsion. Okay, this homework you do yourself, tell the answer in the comment section. Okay, now I'm going with a very important point. Please note, most important point. Okay, please, most important point. Most important. Okay, now listen. First, if central atom, if central atom, okay, having only bond pair is present. Only there are two type of, okay, one is bond pair, one is lone pair. Okay, now first case, if the central atom only containing what, for example CH4. Okay, in this case, okay, carbon, hydrogen, here also hydrogen, this also hydrogen, this side. Okay, this central carbon atom only bond pair. Okay, this similar case. Okay, if central atom having only bond pair, please note angle that equal to standard angle. I will tell what is standard angle. Standard angle. What is standard angle? Trigonal planar, okay, what is angle? 120. Understand? Linear abina 180. We got the point. Okay, this is standard angle. Okay, okay. Next, shape and geometry same. Shape and geometry are same. Son, listen, when this condition applicable now, when central atom do not have lone pair, okay, it have only bond pair now, that case angle equal to standard angle and shape equal to geometry. Okay, general shape and geometry is not equal. Okay, but shape structure same. Okay, so what is shape of the appearance of the molecule? Okay, geometry na is based on bond pair, lone pair, the geometry. What is shape? What is structure na is appearance of molecule. Okay, very, very important. Okay, and second case, please note. Second case, please note. Very, very important. Second case, please note. If central atom present both bond pair and lone pair. Rendume irunduchna, okay, angle not equal to standard angle. Standard angle and shape are not equal to geometry. You got the point? For example, ammonia. Okay, in this molecule, okay, for ammonia, geometry is tetrahedral. Okay, what is shape? Pyramidal. Okay, both are different. Okay, listen, very, very important. Okay, note in exam. Okay, note in exam, they ask geometry means. They ask geometry mean we have to count. We have to count bond pair plus lone pair. Understand? Okay. In exam, they will ask shape or structure. They will ask shape or structure. Only count bond pair, don't count lone pair. Okay. For in this case, okay, take ammonia, CH4, hydrogen and hydrogen. Okay. In the ammonia, the 3 bond pair and plus 1 lone pair. Yes or no? 1 lone pair. Total 4 electron pair. Yes or no? In methane, 4 bond pair and total 4 electron pair. Okay. Now ammonia and methane molecule both have same geometry because their total electron pair is same. Because ammonia 3 bond pair, 1 lone pair, total 4 electron pair. Similarly, methane molecule 4 bond pair, there are 4 electron pair. Okay. Therefore, ammonia and methane molecule have same geometry. But if you're going to encounter the shape, okay, ammonia only 3 bond pair, don't count the lone pair. Okay, without lone pair, look at the geometry. Ammonia, what is geometry? This is a pyramidal, right? Now, in this case, methane molecule, there is no lone pair. Therefore, the geometry and shape are same. For methane, geometry tetrahedral, shape also tetrahedral. For ammonia, geometry tetrahedral, but shape is pyramidal. Okay, you understand? This is a very, very, very important point. Okay, in exam, they are geometry now. We have to count both bond pair and lone pair. In the exam, they will ask shape and structure now. We only look bond pair, forget the lone pair. Now see the appearance of bond pair and tell the shape or structure of the molecules. Okay, this is very, very, very important point. Okay, now I'm going to example with coordination 1, 2, 3, 4. Please note. Okay, coordination 2, okay, 1, 2 maximum. I go with the 3, 4. Okay, very, very important. Please note. Some people call coordination number and few people call what? Static number. Okay, now basic information. Please note. Please note. Very, very important. Now coordination number is 2. Okay, it means what? The molecule having 2 bond pair. Bond pair count, this is 2. Lone pair count 0. Okay. Now for as a beryllium belong to which group? Listen. First, we need to find out the valence electron of central atom. Very, very important point. How to find a valence electron? Please note. For S block, what is valence electron? Equal to group number. Okay. For P block, what is valence electron? Now, group number minus 10. For example, tin. This belongs to group 14. Then what is valence? 14 minus 10. 4 valence electron. You got the point? Very simple. Okay. For example, okay, I go with what? Bismuth. What is group number? It's a 15 group number. Now, what is valence electron? 15 minus 10. Answer is 5 valence electron. You got the point? Now, S block, for example, beryllium, which 2s group, they have 2 valence electron. Understand? Lithium, how many? 1 valence electron. Therefore, this having 2 valence electron. Okay. What is the molecule? BeCl2. Okay. Cl is for monodentate ligand, right? It means they only form single bond. Okay. Therefore, the beryllium having 2 valence electron and dot dot, it make a Cl and Cl. Okay, in this molecule, how many bond pair is present? 2 and lone pair 0. Therefore, what is geometry of this molecule? Geometry is linear. What is angle? Is 180. What about the shape? Because this beryllium Cl2, listen, shape only for central, not surrounding atom. Okay, because this Cl is 7 valence electron. Therefore, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6, 7. It have lone pair and surrounding atom. But if you want to find out the structure geometry, we have to only look at the central atom. If the central atom having lone pair, then see the molecule. Okay. Now this beryllium having only 2 valence electron. The two valence are involving bonding. Therefore, there is no lone pair. Okay. Therefore, the beryllium, what is geometry? Linear. What is shape? There is no shape because there is no lone pair. Okay. Whenever the molecule having lone pair, that only shape going to generate. Okay, this is the first example. Okay, listen, one lone pair, one bond pair is not possible because the lone pair is fatty. Okay, and bond pair is thin. What is fatty mean? What? That lone pair occupy maximum portion of molecule. It become what? More repulsion with the bond pair because the molecule become unstable. Therefore, one bond pair and one lone pair is not possible. Okay, I understand. Then I go with the next example. Please note. Steric number or coordination numbers. Steric number 3. In this case, listen. Okay. In this case, first case, bond pair is equal to 3 and lone pair is equal to 0. Okay, example BF3, BF3. Now, which is central atom? Boron, group 13, P block. What is how to find a valence electron? Group number minus 10, group number 13 minus 3 valence electron. Therefore, 1, 2, 3, 3F, 1F, inga 2F, inga 3F, right? Now, this boron molecule having how many bond pair? 3 bond pair, 0 lone pair. Therefore, what is geometry? Trigonal planar. Trigonal planar. You got the point. What about the shape? There is no shape because boron do not have lone pair. Okay. Second case, bond pair is 2. Okay, and lone pair is equal to 1. Okay. Example is SO2. SO2. Now, sulfur belongs to sulfur is group 16, right? There are almost 6 valence electron. Okay, this is 1, 2, 3, 5, 6. Okay. Now oxygen double valent, right? Therefore, this oxygen, okay, and this oxygen. Now this is lone pair. Listen, we don't count the pi bond. Okay, during count the bond. Listen, what is bond pair? Now only sigma bond. Please note, sigma bonds are bond pair. Okay. Therefore, this how many bond pair? 1, 2, 3, 4 na strong. Okay. How many bond pair? 2 bond pair. Okay, and 1 lone pair. Okay. Now 2 bond pair. 1 bond pair, 1 bond pair. Okay, 2 bond pair and 1 lone pair. Now, what is geometry? Okay, if you're going to find out the geometry now, we have to count both bond pair, lone pair, right? What is total count? 3 electron pair. Whenever the molecule have 3 electrons, what is geometry? Trigonal planar. Trigonal planar. Okay. If you're going to find out the shape or structure, okay, we have to only count bond pair, right? Therefore, look now forget the lone pair. Look the bond. What is appearance of this SO2? Is like a V, right? V shape, or we call bench shape. You can't define. What is shape? It is a V shape or bench shape, and some people call angular shape. Angular shape. You got this? If you want to find out geometry, we have to count both bond pair and lone pair. Okay. If you want to count out the shape and structure of the molecule, we have to only count bond pair. Now look the bond pair appearance. Forget the lone pair. Look the bond pair appearance. What is the bond pair appearance? That you have to mention the shape of the molecule. Okay. Now the SO2 like what? Bench shape or V shape or angular shape. Okay. This is very, very important. Okay. Now listen, 2 lone pair and 1 bond pair is not possible. Okay. Now just I go with the steric number 4. This is very important. Please. Steric number 4. Most important. Most important. Case number 1. Bond pair is 4 and lone pair is 0. Okay. Now, X base methane CH or BH4 minus. Okay. Now, so methane is simple example. I go with the BH4 minus. Okay. Boron is group 13. Okay. Boron having group 13. Therefore, 3 valence electron. Malor minus 4 valence electron. Carbon la boron la 4. Okay. 1, 2, 3, 4. Therefore, hydrogen 4 hydrogen. 1, 2, and 3 and 4. Okay. Now this BH4 minus having what? Having 4 bond pair and lone pair, 0 lone pair. Therefore, okay, total electron pair 4. What is the geometry of this molecule? Tetrahedral. What is the bond angle? 109, 28 minutes. Okay. Tetrahedral. Shape because BH4 minus. This minus not lone pair. Okay, please understand. This minus electron involving this electron. Okay, therefore another hydrogen can form. Okay, otherwise the molecule should be BH3 only. How the BH4 minus? This one electron involving the bonding. Okay, they give the electron to the hydrogen atom. They give the electron to the boron atom. The hydrogen can connect with that hydrogen, that electron. Okay, they form BH4 minus. Okay, this minus is not a lone pair. Okay, now what is the geometry of this molecule? Tetrahedral. Because BH4 minus there is no lone pair. Therefore no shape. Okay, now second case, very important. Bond pair count is 3 and lone pair count is 1. This example, ammonia, NH3. Nitrogen group 15, 15 minus 10, 5 valence electron. Therefore, 1, 2, 3, 4, 5. Hydrogen monovalent, 1 hydrogen and 4 hydrogen and 4 hydrogen. This is lone pair. Okay. Therefore, bond pair is 3, lone pair is 1, total electron 4. Therefore, geometry is tetrahedral. Okay, listen. Ammonia, so BH4 minus having total electron pair 4 because 4 bond pair, 0 lone pair. Okay. In ammonia, 3 bond pair, 1 lone pair. Total electron should be 4. Therefore, BH4 minus ammonia, both are same geometry. But ammonia having lone pair, the shape will be different. What is the shape of this ammonia? How to find out the shape? We have to only count bond pair. Forget the lone pair. Okay. Now forget the lone pair. Now look the appearance of what is appearance of bond pair. It's a pyramidal shape. Very, very important. Okay. Now third case, the lone pair is 2, again bond pair is 2. Okay, example what? Example is water molecule, simple example, water molecule, H2O. Oxygen 16 group, okay, therefore valence P block element, valence electron, group number minus 10, upper 16 minus 10, 6 valence electron, therefore 1, 2, 3, 4, 5, 6, hydrogen monovalent, they form hydrogen, or hydrogen, okay, here lone pair and here lone pair. In this case, total electron count 2 plus 2, 4. The geometry is tetrahedral. What is shape? If you want to find out shape, only look bond pair, right? It's like SO2, similar to SO2, right? Now, this is a V shape. This is a V shape or what? Angular shape. Okay. Now see this molecule. Germanium CH3 4 times. Okay. This is equal to this germanium H4. How now? Listen. Now hydrogen having 1 valence electron, right? CH3. Actually, carbon 4 valence. 1, 2, 3, 4. Here hydrogen. This is hydrogen and this hydrogen. Therefore, 1 electron is available, right? Listen, this hydrogen also 1 valence electron involving the bonding. This also having 1 electron involving bonding. Therefore, this hydrogen, this CH almost same. You got the point. Therefore, this geometry data, this geometry data. What is Germanium shape? The Germanium, inga CH3, inga CH3, inga CH3, inga CH3. You got the point. They will give this like a substitution. They will confuse the question. Okay. Listen, hydrogen is 1 electron. Total available electron 1. In CH3 also, what is available electron 1. Therefore, similar of hydrogen and CH2 going to make a bond like a hydrogen atom. Okay. These are both are the same geometry. Okay. There is no lone pair. There is therefore no shape. Okay. In case of water molecule, they have 2 bond pair, 2 lone pair. Total electron 4. Geometry tetrahedral. What is shape? V shape illa angular shape. Illa some people call what? Bent shape. Okay. Now this is coordination number 4. Now it's very, very important. Coordination number 5. Okay. In this till now, okay, only one geometry. Okay. Coordination 3 na trigonal planar. Coordination number 4 tetrahedral. In case of coordination number 5, there will be 2 possible geometry. One is what? Trigonal bipyramidal. What is another one? Square base pyramidal. Okay. Now I'm going to tell which case they form square planar, square base pyramidal, and which case they form okay trigonal bipyramidal. Please. That is coordination number. Some people got steric number that equal to 5. Okay. Case number 1. Okay. Initial listen. Initial I will tell this like please. Case number 1. Case 1. Bond pair is 5. lone pair is 0. Okay. Now in this case, two geometry first. One is trigonal bipyramidal. What is the other geometry? Square base pyramidal. What trigonal pyramidal? This trigonal metal 1, 2, 3, 4, 5. This is what is square pyramidal metal 1, 2, 3, 4. This okay. This is square base pyramidal. This is trigonal bipyramidal. Okay. Please note. Very, very important. Please note. Most common now. Okay. Maximum. Okay. Note. The maximum compound. The maximum. This way. The maximum compound. The maximum case. The main group element. Okay, with steric number or coordination number 5, the most common geometry is trigonal bipyramidal. Please note. Okay, trigonal bipyramidal is more stable than square pyramidal. Okay. Now, what is the challenge? That when the square base pyramidal, some people call square base pyramidal and few people call square pyramidal. Okay. When the square pyramidal can be exist, I give you the condition. Whenever I give the two condition. Okay. Whenever the molecule obey the two condition, that case what? The square pyramidal is more favor over the trigonal bipyramidal. Okay. Now, what are the two conditions? Please note. The condition for what? This is the condition for square pyramidal. Okay. Condition number 1. Sorry. Please note. Just wait. Condition number 1. Just wait only. Just wait 1 minute. Okay, this is what I cannot drop this one. Erase. Okay. Listen. Condition number 1. What is the condition? First condition, please note. See the central atom. Okay, central atom. If belong to fourth or higher period. Fourth or higher period. Okay, 4 3 okay, 4 higher period. First condition. Second condition. Okay, see the central atom. See the surrounding atom. See the surrounding atom. See the surrounding atom. See the It have bulky or bigger. Bulky or bigger group. Okay, substitution group. Example, phenyl C6H5 or CH2 C6H5 or mesytyl group. What is mesytyl? Benzene. In a group attached. Inga or ME. Metal central atom. Okay, this is mesytyl group. Okay, whenever this bigger and bulky group, okay, surrounding atom bigger bulky or bulky atom. central atom on the fourth or adhikimala period irundhuchna, and that case they will square pyramidal can possible. In other case what? Trigonal bipyramidal. Okay, I give you a basic example, please note. Examples. This is very important exam question. Okay, PCl5 morning, nitrogen, phosphorus, arsenic, antimony, bismuth. This is second period. This is third period. This is fourth period. This is fifth. This is sixth. Okay, these three are important. Okay, phosphorus. Whenever central atom having phosphorus, okay, even bulky substitution also what? The square pyramidal not possible because phosphorus belong to third period. Okay, whenever central atom belong to fourth or above fourth period, that case square pyramidal can possible. Okay, in case of phosphorus, okay, C6H5 and 5 times. This is what? Pentaphenyl phosphorus. Okay, this is what? Phosphorus belong to third period. Please understand that. What is geometry? This trigonal bipyramidal. Similar same case, arsenic. Yes, inga C6H5 and 5 term. Okay, this arsenic belong to fourth period, and CCH5 is bulky. Therefore, this is square pyramidal. Square pyramidal group. Most important. Please note. Similarly, SB, okay, pH5. Phosphine. pH na idam. CCH pH. Okay, va? pH. This also what? Square pyramidal. You got the point, right? I will give like a flow chart. Just wait. Just wait. Okay, condition is same. So condition is correct. Okay. Now see that. Now see the examples. This okay. This is BR, PBr5. Okay, and phosphorus Cl5, and SB Cl5, and SB PR5, and AS Cl5, and phosphorus CH2 C6 H5 5 times. Okay, this molecule, this complex are this one, this complex, sorry, this complex, okay, this complex, what is geometry? Trigonal bipyramidal, because central atom or either central atom is what is below fourth period. Okay, now in this case, please note SB pH5. The past in the CH5 pH. Okay, pH 5 times, or AS, okay, pH 5 times, or AS CH2 C6 H5 5 times. Okay, this three molecule, what is the shape? This molecule, son. This three molecule obey what? Obey condition A and B, right? A and B. Therefore, this is what? Square pyramidal geometry. Okay, square pyramidal geometry. Okay, this is very important. Please note it. Okay, exam. Okay, now I go with some important thing. Please note. This is a higher level concept. Please note. Okay. In group number 13. In group number 13. Okay, group number 13 are now. This also form a steric number 5. Okay, what is geometry? That is for trigonal bipyramidal. Okay, for example, okay, germanium, boron, wait, boron, aluminium, okay, germanium. So germanium Cl5 2 minus. Wait, carbon, gallium. Okay, this gallium Cl5 2 minus. Okay, this gallium belong to group 13. Therefore, 3 valence electron minus 1 plus 2 5 upper. What is geometry? This is trigonal bipyramidal. Okay, but abnormal example, please note. But abnormal example. Okay, in this case, indium F5. This is 2 minus. This is what? Square pyramidal geometry. This is square pyramidal geometry. Okay, this you have to learn it. Okay, because this is surrounding atom. F is small group, right? Whenever bulky group na square pyramidal can be possible. In case of indium Fi 2 minus, okay, experimentally what is geometry of the structure? Square pyramidal, not trigonal bipyramidal. Okay, this is about what? First case 5 bond pair and 0 lone pair. Okay, and second case please important. Second case bond pair equal to what? 4, lone pair equal to 1. Okay, SF4, this example, SF. Okay, sulfur belongs 6 valence and therefore, okay, listen, very important now. 1, 2, 3, 4, 5, 6. Okay, listen. In case of tetrahedral, okay, tetrahedral metal kuda 1, 2, 3, 4. Okay, listen. In tetrahedral, all bond angles are same. Yes or no? What is the bond? 109, 28 minutes. Okay. Whenever the all bond angles same, we can put the lone pair any bond pair. So if you remove any bond pair, we can put the lone pair. Is no problem because all bond angles are same. But in case of trigonal bipyramidal, okay, now there are two set of the combination. What combination now? One is the trigonal planar combination. One is linear combination. Okay, this is angle is 120 and this angle is 180. Now what is the challenge now? If you're going to remove the one bond pair, you're going to put one lone pair now. Where are you going to put the lone pair? Okay, either this geometry, either this one. This one. There are two types. This is an equatorial bond. This is an equatorial bond. This is an equatorial bond. This is an axial bond. Now this axial bond. Listen, in case of methane, all bonds are same. But in case of trigonal bipyramidal, they have two set of bonds. Okay, the 3 bonds are equatorial and 2 bonds are axial. Okay. Now what is our challenge now? We're going to put the lone pair either equatorial or axial. Please note. Shift note. Very important. Note. If the molecule in trigonal bipyramidal geometry, okay, we're going to put one lone pair now. We are going to put one lone pair now. You have to put what? We have to put in equatorial position. In equatorial. We got the point. The 2 lone pair now, we have to again put what? Put equatorial position. Okay. Yes or no? In 3 lone pair now, we again put what? Equatorial pair. There is no lone pair in axial position. Okay, please understand. This is a very important point. Okay, in trigonal pyramidal geometry, if we're going to replace bond pair by lone pair now, where we're going to replace? Okay, we remove the equatorial, then put the lone pair. Don't put the lone pair in axial position. Okay. Now I will show these 3 examples one by one. Now see, very interesting, right? Now this one case, first case, 1, 2, 3, 4, 5. Second case, 1, 2, 3, 4, 5. And third case, 1, 2, 3, 4, 5. Listen. In first case, I go and remove the axial equatorial, right? I remove this equatorial position, for example. I put the lone pair. Because 3 equatorial same, right? In first case. This you have to draw this like metal. This is axial bond. This is axial. Okay. This is equatorial bond. This is equatorial bond. This is the lone pair. You got the point. Therefore, this one, this is shape. Okay, shape down. Shape is what? Like a seesaw. Listen, in all 3, okay, listen, whenever the molecule of same electron count should be same now. For example, 5 bond pair and 4 bond pair plus 4 lone pair and 3 bond pair plus 2 lone pair and 3 lone pair plus 2 bond pair. Okay, all these 4 case, but total electron count should be 5. Okay, the geometry is trigonal planar. Okay, now going to encounter only the shape of the molecule. Okay, in the first case, 1 lone pair I put. First case, bond pair is 4 and lone pair is equal to 1. And second case, and bond pair is 3. So bond pair is what? 3 and lone pair is equal to what? Lone pair is equal to 2. Now where I put the lone pair? Equatorial, right? Now this is equatorial bond, right? I remove this equatorial bond. Therefore, this is metal, central atom. Okay, not metal. This 1, this is 2. Here I put lone pair and this is lone pair. Now what is shape of the molecule? How to find out the shape? Forget the lone pair. Only count the bond pair. What is shape of this molecule? Like a T shape, right? Now what is the shape of this molecule? It's a T shape. Okay. Now where I put the lone pair again equatorial. Therefore, is also lone pair. This also lone pair and this also lone pair. Now what is the shape of this molecule? Look, only the lone pair linear, right? Shape is linear. What is the geometry of this all molecule? Trigonal bipyramidal. You got the point. Okay. Now I will give one by one example. Please. First SF4. Okay. This is CCl4. Not CCl4, right? ClCl. Cl. Wait. Just wait. First SF. SF. Now listen. Sulfur 6 valence electron, right? We discussed sulfur. Here F, inga F, inga lone pair, inga F, inga F. In the molecular geometry வந்து trigonal, bipyramidal. What is shape or structure? That is called seesaw. Okay, that is Cl3. Sulfur belong to Cl belong to 7 valence electron, right? Therefore, 3 now remaining 2 valence electron, 2 now 4, 2 now 2 valence electron, right? 4 electron now 2 pair, right? Cl. This is 1 pair. This is second pair. Here Cl. Equatorial. Sorry, F. Right? Inga fluorine. Inga fluorine. Now, what is geometry of this molecule? Geometry is what? Trigonal, bipyramidal. What is shape? Shape or structure? T shape. Okay, now very important. I3 minus. Listen, in case of I3 minus, okay. Listen, if the molecule gives same molecule, we have to consider one iodine central atom. Okay, now one iodine central atom. Valence group number 17. Therefore, 7 valence electron. 7 plus 1. Therefore, 8 valence electron. Okay. Now 1, 2, 3, 4, 5, 6, 7, 8. Okay. Therefore, inga 1 iodine, inga 1 iodine, inga 1 lone pair, inga 2 lone pair, inga 3 lone pair, mala minus sign. Okay, now this iodine having 3 lone pair and 3 lone pair and 2 bond pair. Now what is geometry? Geo is again trigonal, bipyramidal. What is shape of this molecule? Linear. Okay, linear. Okay, so I'm going to discuss some interesting fact of I3 minus. Please, in exam they ask, not important. It's a common question all entrance exam. I3, they asking what? The number of lone pair. Number of lone pair in I3 minus. Okay. Now same iodine 7 valence electron, 7 minus 1, 7 plus 1, 8 valence electron. Now iodine, inga or iodine, inga or iodine, inga or lone pair, inga or lone pair, inga lone pair. For lone pair count, what is the answer? Answer is 3. What is lone pair count? Answer is what? 9. How is 9? Now listen. Now this iodine, okay, having 7 valence electron, only one involved. About 2, 6, 7. Other 2, 6, 7. Therefore, listen. In exam, they ask for lone pair I3 minus na 1, 2, 3. Sorry. Just wait. Just wait. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total lone pair. Answer is 9. Okay. Either they ask total lone pair or lone pair na 9. Okay. Central atom lone pair. Central atom lone pair. How many central lone pair? 1, 2, 3. Right? Surrounding atom lone pair. That is equal to 6. Total 9. We got the point. I3 minus how many lone pair can total 9 lone pairs. Okay. This is a PYQ question. All understand they will ask this question. Okay. Very, very important. You understand? Now steric number is 6. Simple. Steric number or coordination number 6. Idhula pathana bond pair count 6, lone pair count 0. Okay, octahedral geometry. The central atom 1, 2, 3, 4, 5, 6. Okay, now this geometry is octahedral. Octahedral shape. There is no shape. Okay, now listen. Now same case. Okay, in case of note. In case of octahedral geometry. Octahedral. Again, same like a trigonometry. Okay. Central atom 1, 2, 3, 4, 5, 6. Okay. This also having 2 type of bonds. Okay. This is axial bond. This is axial bond. This is equatorial bond. This is equatorial. This is equatorial. Now, what is the challenge? Where I put the lone pair? Either axial or equatorial. Now, I'm going to give the condition like trigonal bipyramidal. Okay. Now, please know the condition. In octahedral geometry. In octahedral geometry. Okay, geometry. Please note. If one lone pair is present, we put axial position. Where I put axial. Okay. 2 lone pair is present, we put axial. 3 lone pair is not favored in after. Okay, therefore, if we put 4 lone pair is present, we put equatorial. This is a condition. You got the point? 1 lone pair axial upon no, 2 lone pair again axial upon no, 4 lone pair equatorial upon no, 3 lone pair is not favored in octahedral geometry. Okay. Now I will explain. If I remove the bond pair, I put the lone pair. Now we are going to check the shape of the molecule. Okay, same simple example. Please note. Okay, first central atom. 1, 2, 3, 4, 5, 6. Central atom. 1, 2, 3, 4, 5, 6. Again central atom. 1, 2, 3, 4, 5, 6. So hey, all geometry. See, geometry is octahedral. OH. Okay. Now shape is very important. And first case, bond pair is 5 and lone pair is equal to 1. Where I put the lone pair equal to axial, right? Axial position. If I remove the one axial, I go in put the lone pair. Okay. Now what is the shape of this molecule? Now this is a square base distracted. Okay, because listen, this bond pair, this lone pair involving this repulsion, because the lone pair bond pair is heavier repulsion, right? Compared to bond pair. Therefore, this is a distracted square pyramidal geometry. You got the point. Now I put lone pair. You see, remove the bond pair going to remove. This bond pair going to remove. Okay, axial bond pair. I am going to put the lone pair. This one lone pair. This way. One lone pair and 2 lone pair. Now, if you want to find the shape now, we have to only look bond. What is the bond pair shape? Now, see the appearance of bond pair. Forget the lone pair, square planar, right? This is a square planar. You got the point, okay? Now, this is why you're going to remove the 4. In this case, bond pair is 4 and lone pair is 2. In this case, reverse. Bond pair is 2 and lone pair is 4. Okay. Now, where are you going to remove the 4 bond pair? Put the lone pair axial equatorial, right? Now, remove the equatorial. Okay. Remove the equatorial bond. 1 equatorial, 2 equatorial, 4 equatorial. Okay. Now, put the lone pair. 1, 2, 3, 4. What is shape? Forget the lone pair. Look only bond pair. Appearance of bond pair. What is shape? Linear. Okay, this one example. Okay. Now I give you the example. Very simple example. Okay. First example, SF6. Sulfur 6 valence sulfur. Therefore, 1 sulfur, 2, 3, 4, 5. Okay. Second example on the okay, XCF2 XCF2. Okay, XC on the xenon on the 8 valence electron. Therefore, remaining on the 2 involved 4. Okay, total 6. In this case, very important. Xenon 8 1, 2, 3, 4, 5, 6, 7, 8. Okay, wait, just wait. Just wait. Just wait. In this case, 2 bond pair. 1, 2, 3, 4. Just wait. Small, not correction. Just wait. Take XCF4. Take XCF4. XCF4. Okay. Now xenon is for 8. Therefore, 4 surrounding atoms. Remaining 4. 2 para. For xenon. Inge F. Inge F. Inge F. Inge F. Inge or lone pair. Inge lone pair. You got the point. Therefore, what is the shape of this geometry? Geometry 4 plus 2, 6. Octahedral. What is shape? This is a square. Okay. This exam I will tell later. Just wait. Okay. Now go with the coordination number 7. This is very important. Coordination number 7. This is very simple. Bond pair is 7. Lone pair is equal to 0. What is a geometry? Geo. That is for pentagonal bipyramidal. Sorry, pentagonal bipyramidal. Simple. Like a pentagon, right? Cyclobutyl pentagon. This is a pentagon. Bipyramidal in a central atom. 1, 2, 3, 4, 5, 6, 7. Okay. IF5, IF7. Okay. Iodine group 17, there was 7 valence electron. Therefore, what? Iodine having what? 1F, 2F, 3F, F, F, Ingor F, Ingor F. Okay. This is like what? This is what? Pentagonal bipyramidal. Okay. Now, very important. This is the most important. Please. Okay. Bond pair is 6. Lone pair is 1. This is very important. XCF6. Most important example. Very, very important. Most important. This one. Exam point of view. Zana having 8 valence electron. Therefore, 8 na 6 is F is 6. F is more, and therefore 6 bond pair and 1 lone pair, right? And F, XC. 1 F, 2 F, and 3 F, 4 F, and 5 F, 6 F, inga or lone pair. Okay, this molecule geometry. Geometry is what? Trigonal. Geometry on the pentagonal. This way. Geometry we have to count both bond pair, lone pair, right? Therefore, 5 bond pair and 1 lone, 6 bond pair and 1 lone pair. Okay, what is the geometry of this molecule? Pentagonal bipyramidal. What is the shape? Very important. Okay, if we want to find out shape now, we have to only count the bond pair, right? How many bond? 6 bond pair. This octaedral. Now this lone pair and this bond going to another ripple. Therefore, this is a distracted octaedral geometry. Octahedral geometry shape. Okay, distracted octahedral shape. This is very, very important. Okay, this is very, very important. Okay, this is about state number 8. This up to CSL level, gate level questions. Okay, jam level. This is enough. Okay, another concept limitation of VSEPR. I upload the video in group. Okay, I already upload the video in YouTube channel. I give that link in description box. You can click the link if you want to learn the limitation of VSEPR theory, and please watch. Okay, this is very important. That is limitation. I explained 2 concepts. One is for stereochemically active lone pair and stereochemically inactive lone pair. Okay, I hope to understand the VSEPR theory is very, very important. This type of question asked in all the common entrance